Hey everyone, my name is Krishnavini, and today I'm excited to walk you through my production ready end to end MLOps project that incorporates CI/CD principles to ensure seamless integration and deployment. Let's understand the basic terms used in this video about insurance. Health insurance is a policy designed to cover medical expenses for illness, injuries, or other health related conditions. On the other hand, vehicle insurance is a policy that provides financial protection against damages or losses to a vehicle due to accidents, theft, natural disaster, or third party liabilities. Now, let's think from the company's perspective. As many of you know, insurance companies often struggle to identify the right target customers. Well, that's exactly where my project comes in. The ability to predict customer interest in vehicle insurance has a direct impact on the business. With accurate predictions, companies can focus their marketing efforts on the most promising customers, ultimately improving resource utilization, conversion rates, and overall campaign efficiency. The main objective of this project is to predict whether a customer who already holds a health insurance policy would be interested in purchasing vehicle insurance. We base these predictions on customer demographics and their existing insurance status, giving the marketing teams valuable insights for strategic decision making. For this project, I used a dataset containing customer records, including information on health insurance, vehicle insurance, and customer demographics. This data is key to building a robust model that can predict customer interest in vehicle insurance. After performing the exploratory data analysis, these are the key insights from the data. Compared to females, male individuals are more likely to purchase the vehicle insurance. Teenagers and middle aged individuals are more likely to be interested in vehicle insurance. Most of the customers pay lower annual premiums, with a few paying significantly higher premiums due to the factors like coverage level or vehicle type. Customers with vehicles older than 2 years have a higher probability of purchasing vehicle insurance, while those with vehicles aged between 1 to 2 years show a higher percentage of interest in purchasing the vehicle insurance. 45.8% of the customers were previously insured, and 12.2% of them show interest in buying vehicle insurance again, indicating awareness and willingness to invest in. Now let's check out the project architecture and understand how everything is interconnected. This architecture represents the end-to-end workflow of my machine learning project, built using ZenML and MLflow with Streamlit interface for user interaction. From data ingestion to model evaluation, I have constructed a robust training pipeline. This pipeline automates the process of preparing data, building the model, and evaluating its performance, ensuring consistency and efficiency. We start with data ingestion step, where raw data is collected and prepared for analysis. This is followed by exploratory data analysis and data visualization, where we explore patterns and insights from the data set. Once the data has been explored, it undergoes data cleaning, where missing values and inconsistencies in the data are handled. After this, we perform feature engineering, where new features are created or existing ones are transformed to enhance the model predictive power. Next, we handle any outliers to ensure the data is robust, followed by data splitting into training and validation sets. Since this project deals with imbalanced data, oversampling was applied to balance the classes. The processed data is then used for model training, where multiple algorithms are tested and fine tuned. The results are evaluated during the model evaluation step, ensuring we achieve the best possible performance metrics. ZenML acts as the backbone of this pipeline. It ensures that each step of the workflow is reproducible and well organized. It also captures outputs from each step, called artifacts, to ensure traceability and debugging when needed. For experiment tracking and model deployment, ML flow is integrated into the pipeline. It logs all the parameters, performance metrics, hyperparameters, and model artifacts, providing complete transparency and control over the process workflow. Finally, once the model is trained and deployed, Streamlit serves as the interface where users can interact with the system. The users input data through this interface and predictions are generated in real time. For example, in this project, predictions are made about whether a customer is likely to buy vehicle insurance. Now that you have understood the project architecture, let me show you the backend how this is built. We have two pipelines, deployment pipeline and training pipeline. This training pipeline is responsible for all the steps starting from data ingestion to model evaluation. Now let me show you by running this pipeline. Just type Python run pipeline to run this training pipeline. Let's check out the dashboard of ZenML. This interactive ZenML dashboard will help you to better understand each and every step of your training pipeline. Now that we have explored the training pipeline, let's move on to the deployment pipeline. This pipeline will initiate both the continuous deployment and inference processes, ensuring seamless integration. There you go. Our run deployment pipeline has run successfully. The continuous deployment pipeline has initiated, and then each and every step was again executed. Then the inference pipeline was initiated. This inference pipeline is responsible for making predictions. Let's refresh this ZenML dashboard to check the continuous and inference pipelines have been added or not. Here you go. These two pipelines are being added to the dashboard. When we click on this continuous deployment pipeline, these are my previous runs. This is the latest continuous deployment pipeline. Here also you can see all the steps which are continuously deployed. Now let's see the inference pipeline. Using the prediction service loader, we will make the predictions in this inference pipeline. Now check the ML flow experiments that were tracked. Copy this URI and then paste it and run. Here everything is being tracked by ML flow. All the metrics are being listed here, and every step what all encoding we have done in the backend has been recorded here. Here we can see the ROC curve show 82%, which is pretty good. Let's run the Streamlit app to check out the front end. After inputting your data, you can click on predict to make the predictions. There you go. Model has given the response as 1, which means the customer is eager to purchase the vehicle insurance. This entire workflow from data ingestion to real-time predictions is automated and scalable. While I've run it locally, ZenML gives us the flexibility to scale the solution to cloud platforms as well. This project combines robust tools and frameworks like ZenML, MLflow, Streamlit to deliver a production-grade end-to-end MLOps solution. I have kept this explanation concise to focus on the most critical parts of the project. I hope you found this project informative. You can access the detailed project resources and code in this GitHub repo. Thank you.